Okay, class, this is the second part of the explanation of vectors addition, and in this video we learn how to add vectors by the Polygon method. And we'll solve this exercise, and the first thing we have to do is to represent that information, the information given in the exercise, in a vector system. And the first thing we have to do is to trace the axis of the Cartesian plane and define a scale. In this case, for me, the scale is 1 centimeter will be equal to 1 kilometer. But you can define or establish a different one according to the space you have in your millimetric paper sheet or notebook. So the first thing we have to do is to identify the vectors in the word problem. So the first vector is 3.5 kilometers, that's the magnitude. Then we have the sense, the northeast, and we have the direction, 40 degrees. Okay, magnitude, sense, direction. So we will represent it in the plane. So this is the direction and this is the magnitude. Then we have to identify the second vector. The second vector is in the northwest, direction 70 degrees, and then magnitude 3 kilometers. So this is the vector. And the last vector is still in northwest. This is the direction 20 degrees, and this is 5.5 the magnitude. And this is the third vector. Okay, so this is our vector system. If you check, the information given in the word problem is represented in this system. Now we will find the displacement or the resultant vector, by the addition of these vectors, and we will apply the Polygon method. The first thing we have to do is to trace a reference plane like this. In this reference plane, we will trace the first vector, the vector in red. Okay, I'm considering the same direction, the same magnitude. Now, in the head of the arrow, in this head, I will trace another reference plane. This reference plane will be for the second vector. So I will trace the second vector and I will consider the same direction and the same magnitude. Now, check that this direction, these 70 degrees, are measured from the negative x-axis to the vector. But remember that actually the direction is 110 degrees because the angle should be measured from the positive x-axis to the vector. Okay, just keep it in mind. Now, in the arrow, in the head of the arrow of the second vector, we will trace another reference plane. In this reference plane, we will trace the last vector. This is the last vector with the same angle and the same thing. This 20 degrees, this direction of 20 degrees is actually 160. Okay, now with a ruler you will measure the distance between the final point, which is this is the final point, and the initial point. This is the starting point. So you will measure this distance. This distance represents the displacement. In our case, is the resultant vector. And you have to have value for a result. Remember that this method is not an accurate method, but you have something similar to 7.5 kilometers. Okay? Now, with the information given in this video and in the topic explanation and in the previous video, you will be able to solve this exercise for homework. You have to represent these vectors A, B, C, D in a vector system, and you have to determine the resultant vector, it means the displacement, by both methods, the Polygon method and the analytical method. And this will be the first exercise. And the second exercise is to complete the exercise that you started in class. You have to determine the resultant vector of the vector system seen in class, but now by the Polygon method, and compare the result with that you got by the parallelogram method. And that's it.